How much wealth would you expect a single asteroid in space to contain? Maybe $1 billion worth? That would be pretty good. How about 10 billion or even $100 billion? Well, according to studies published by NASA, a single asteroid with a diameter of 1,000 meters under the right conditions could contain as much as $50 trillion worth of resources according to current prices on Earth. That means that from a single asteroid, it would be theoretically possible to harvest as much as half of the entire world's GDP, causing asteroid mining to be not only the most profitable business on Earth, but in the entire universe. And within our solar system alone, we've already found over 2 million asteroids of this size. And the largest asteroid, which we call Ceres, sits right here in the asteroid belt between Mars and Jupiter, with an astounding diameter of just about 600 miles. And if fully harvested, according to current prices on Earth, would be worth about $10 quintillion, which is 95,000 times more than the entire wealth of our planet combined. That means every single country, every single government, every single person, every billionaire, and every secret Illuminati person, all of that combined wealth, and it's not even 1% of the potential wealth from just a single asteroid in our solar system. And the reason why asteroids are so valuable has to do with a few things, starting with the amount of resources available on planet Earth. You see, on our planet, we have a bunch of metals that are extremely rare but super useful, and we call these precious metals. And these metals are a very finite resource on Earth, with many of them, such as gold, being almost completely mined out already. And while a lot of the price of these metals is driven by the fact that we've already harvested most of them, there's also a second aspect that will allow them to still retain value even if a massive amount flooded the market due to mining from an asteroid. Because not only are these metals rare, but they are outstandingly useful. And they're commonplace in almost every single part of modern day life, so much more than you would ever imagine. Life as we know it would not exist without the hardware that we've created using these precious metals. For example, one of the most valuable metals we can mine in space is this right here, platinum. This metal is super useful in creating technology because it's highly durable and resistant to corrosion while also being an amazing catalyst and conductor of electricity. Considering the rate at which platinum is used in modern technology, and there's potentially as much as dozens or even hundreds of dollars worth of platinum in the very device that you're watching me with right now. Additionally, it's also used in things that you would never even expect, like medicine. Platinum is extremely important for chemotherapy because it inhibits the growth of cancer cells. And due to its biocompatibility, it's in a ton of medical devices such as defibrillators. And as just a really rough estimate here, probably about 10 or even 20 million lives are saved every single year as a result of things that contain platinum in them. And this is just one of those precious metals. It's just touching the surface. There's so many other metals such as silver and gold, but an even rarer category of metals that also exist on asteroids such as iridium, rhodium, and palladium, all of which are used in very similar ways for important things such as electronics or even just purifying the water that you drink on a daily basis. If all of the precious metals on Earth ceased to exist overnight, life would completely revert back to the Stone Ages. There would be no electricity, no technology, no medical care, no vehicles, no economies, no machines, no energy, and we could really only do things made out of wood, stones, and fire. But these resources on Earth are rare and very limited, and that's part of why everything that contains them is so expensive. Imagine an iPhone that costs just $100, or a car that you could buy completely brand new for $5,000, or anything that's made from metal in general just costing 10% of the current price it is right now. This is the future that we can build through asteroid mining. To help you further understand how truly limited our resources really are, if it were humanly possible to collect all of the entire world's mined platinum and put it all together in this cube right here, this is how much platinum the Earth contains. Now, while this is about 10,000 tons of platinum, it all fits right here into this one single cube, which sits only at about 8 meters long on every single side. And since it's an 8-meter long cube, chances are this cube right here could fit in the very room that you're watching this video from right now. However, asteroids are in a sense almost magical when it comes to these resources. You see, on Earth, as a part of our original planet's formation, the majority of our precious metals all fell down deep into Earth's molten core, where it's now completely inaccessible without destroying our planet altogether. This happens as the metals are just heavier than dirt and soil. And so they naturally fall down, but it also gets accelerated due to things like tectonic plate shifting, geological changes, or even just the weather and erosions over time. Whereas asteroids in our solar system are remnants of leftover pieces that formed from the planets. They never underwent any type of planet formation process. And since asteroids are essentially just big-ass boulders in space, they don't have those same tectonic plates or geological changes or weather issues. And so the metals falling further and further into their core is something that doesn't really happen. And all of this is to say that most of the metals that we can find in an asteroid are generally much purer and way easier to access than the ones that we can mine on Earth, especially as they've remained completely untouched for billions of years. And so the scientists' estimates and studies from NASA place the abundance in resources in asteroids to be about 1,000 times denser and more abundant than on planet Earth. Now, all asteroids are of course much smaller than planet Earth, but a single decently sized asteroid containing as much resources as planet Earth as we've mined throughout all of history is very realistic. In fact, there's millions of those very same asteroids already right nearby in our solar system. As an example, here's one of the biggest asteroids in our solar system, Ceres. Now, Ceres' immense value comes from outrageous deposits of a little bit cheaper metals, but it also contains astounding amounts of platinum. And so let's just forget all the other metals it contains, which is 95% of the value, and only see its platinum for a moment. Well, from the measurements from NASA, it's estimated that Ceres contains about 10 million tons of platinum. And that amount alone from just this one asteroid would single-handedly exceed the amount of platinum that's been mined on Earth since the dawn of time 1,000 times over. And it would also be at an estimated value of about $290 trillion, which is more than 3 times of the entire wealth of everything on planet Earth combined. Now, of course, when I say, hey, this asteroid has $10 quintillion worth of resources, that's obviously not entirely true, because if you just brought all those resources to planet Earth all at once and sold them, the price would collapse. And you probably wouldn't even be able to sell most of it. After all, who can buy $300 trillion worth of metals when the entire wealth of planet Earth is $105 trillion right now? That doesn't change the fact that they're also extremely useful and one of the most important things to our society. And even if there's a surplus of supply, there's always going to be a strong demand for these metals. Even if it might cause the price to go down, it's still going to be incredibly profitable. Because all of the world's companies, all of the richest people, all of the billionaires and governments in our entire life as it exists are all built off of things that would benefit from asteroid mining. Now, of course, the big question here is how realistic is asteroid mining really? And that is the big question. And to put it simply, it's going to be difficult. But you can bet that this industry is going to create the first chain of established trillionaires if it can be developed in the next few decades. And let me tell you, rich people are very aware of this. Many companies and investors have already started heavily funding research and development of asteroid mining technology. And when I researched this, I found that it's so much closer than I originally expected. Even governments are involved too. The United States in 2019 signed an executive order to support mining the moon and asteroids, paving the way for a global policy for mining in space to now be fully legal and allowing for private citizens to own the resources they mine, but without needing to claim ownership over the body of resources that it sits on. Essentially allowing asteroid mining to no longer violate our Global Outer Space Treaty of 1967. As a result of this policy, alongside NASA's new Artemis program, the USA is aiming to establish a long-term sustained base on the moon by 2028, eventually aiming to also land on Mars in a similar timeframe. And with these missions, NASA has been contributing significantly along the way to asteroid mining technology. And as well, a sustained base on the moon would be one of the most monumental things to allow asteroid mining to be possible. And I'll explain why in just a bit. Many other businesses, such as the United States company Astroforge, have already made significant strides to be able to successfully mine from asteroids. Astroforge has already secured immense funding and completed technology demonstrations. And in 2023, they completed a mission in partnership with SpaceX to successfully refine asteroid material in space, which completely proved that asteroid mining will be possible. That mission was a complete success, and they're now gathering and studying further data from asteroids about the information of their in-depth contents and physics, which is also being done with further assistance in partnership with NASA. And this is all being done with serious plans in mind to do their first landing on an asteroid and try mining it as soon as 2025. Just see what the CEO of Astroforge, Matt Gielek, has to say about the realities of this.
For us, we have a very clear plan to do our first, to actually bring back our first amount of metal by the end of this decade. And that's what we're holding to on a very kind of crystal clear schedule for us. One other thing I'd like to touch on here is while we are starting out with mining the platinum group metals, our refinery can mine really any elemental metal. So as we go out there, we can start to mine other materials, bring them back to Earth, as long as the cost reward, benefits us per mission. It's got to be a profitable endeavor we're going after.
And although the asteroid mining industry is still in the early phases, the progress that's been made, combined with the shared research from NASA, indicates that people are doing this really seriously, and that governments, businesses, and investors all believe that this is something that will be possible at some point in the near future. Now, I've thrown around some crazy numbers in this video because I'm just so excited about this, so let's see an example of a more realistic scenario of what asteroid mining might actually be like and what it would cost. Because of course, we aren't going to just march up to Ceres and mine it instantly and then return home and everyone gets rich. That's not realistic at all, and even asteroids in the asteroid belt are fairly difficult to access. But there's loads of asteroids that just fly by Earth on a regular basis. And these ones are all fully accessible to us, not to mention that we could always start by mining resources from the moon as well. And then as things progress, we can develop systems for refining and shipping from there. Now, for us to actually mine an asteroid and then ship the resources down to Earth, first we have to have all the technology developed to actually do it, and then we also need to be able to easily identify how valuable a passing asteroid would actually be. So that way we wouldn't waste our resources on mining a worthless asteroid. Then we need to launch a space shuttle with our tech and equipment and then land on the asteroid itself. And then we can start mining the metals from it, but so far, this is all kind of the easy part, actually. And it's what's already heavily in progress for being developed. Let's hear a bit more from the experts that are building the robotic tech for this right here.
There's also in an excavation step, there can be, say for asteroid work, there's the transastre concept that uses intense sunlight to excavate while simultaneously doing the extraction step. Sometimes some of the processes kind of separate those steps, but in the transastre concept, they're combined. You excavate and extract at the same time.
So we definitely can mine asteroids. The hard part is what comes after. We have to collect all of the ore from the mining process, but it's not economically viable to just ship a bunch of asteroid dirt back to Earth, especially as each launch of a shuttle and cargo could be costing tens of millions of dollars. So the big thing, the real problem for asteroid mining to become the thing of dreams and to create trillionaires, the big problem we need to solve is to refine the metal in space before shipping it home. Because when you refine the metal in space, we just get the pure form of what it is, and so the volume and mass is incredibly small compared to the overwhelming amount of dirt that it starts from. And this refinement is probably the biggest challenge of asteroid mining currently, as it would probably require some sort of established refining center in space somewhere, plus the ability to ship that dirt from the asteroid to the refining center. To put this all into perspective, on Earth, to refine a single gold bar like this one right here, that's worth about $300,000, well, first we have to start with about, 2 million pounds of dirt, which then gets all crushed up and separated from the dirt using these physical and chemical processes, and then it gets refined into maximum purity from smelting it into a bar. Now, while asteroids are more pure than the dirt on Earth, it's still a massive process, and the business of asteroid mining is much more about asteroid refinement rather than the mining itself. Which that part is a little bit daunting, but not too bad at all. Really, the shipping challenge is shipping it from the asteroid to the refinement center, since it's such a massive volume of dirt, but once it's refined into a pure metal, it's not that much mass to deal with anymore. And remember our little platinum cube from before, maybe not all of it, but certainly half of it could fit into an already normal-sized spaceship. So certainly, while shipping resources home from space will be expensive, it's not going to be that challenging. But that's once the metal is refined already, which is again the main concern. And so this is to why, as a starting point, asteroid mining isn't initially meant to deliver resources to Earth, but rather it's meant to just stay in space and be used in the production of further spacecraft and space equipment, almost as a infinite space shuttle glitch. And it'll also serve to further advance the space technology through an established and developed base in space, such as the one that NASA's building on the moon. And while NASA has many goals for the Artemis missions, the idea of a sustained base on the moon, it's the entire foundation that the asteroid mining industry really needs. If we had a proper moon base that was operated year-round, we could mine an asteroid, ship that dirt to the moon, and then use it for space technology or eventually ship it to Earth. Or to keep it much simpler, even just start by mining things from the moon, although the moon is way less resource dense than asteroids. Or alternatively, if I'm being outrageously optimistic here, we could one day mine from the asteroid belt, such as our beautiful asteroid Ceres, and then ship the asteroid dirt to a base on Mars. Now, obviously, a lot has to happen before that's anywhere realistic, and the cost would certainly be immense, but hey, we can all dream about what's possible, right? Anyway, these things, establishing the technology to mine successfully, building a base on the moon, and having the infrastructure to send and reuse space shuttles for trips to asteroids are all things that we would need to have to really start up this industry, but it's also all things that we're building right now. Then we've also got the costs of each individual mission, mainly the heavy lift shuttle parts and thrusters for travel, the fuel for the vehicles, the cost for any repairs and damage for lost equipment, plus shipping everything and maintaining this whole operation. Now, estimates from NASA for all of this combined expect the current planned asteroid mining missions to cost about $10 billion to start up at a bare minimum, once the technology is developed, and then multiple billions for each subsequent launch thereafter. So with everything put together, it might cost around $30 or maybe $50 billion for us to get this industry going. It's certainly a lot for sure, but definitely within the realm of possibility. But we're not really funding it as much as it needs. You see, NASA's entire budget for each year is about $25 billion, and that's for everything combined. And so with the current resources we have allocated to this, it's probably still going to be a long time. However, again, the problem here is refining the ore. Let's do a sample of the logistics of actually doing that. To refine 16 cubic meters of pure platinum with the amount of density contained in a decently valuable asteroid, you would first have to start with just over 100 million cubic meters of asteroid dirt. However, there would be plenty of other precious metals in that asteroid material too, so it would be more reasonable to say $10 billion worth of material can come from a tenth of that, or about 10 million cubic meters of asteroid dirt. That might sound like a lot, because it is, but the biggest refineries on Earth are actually processing as much as 1 to 5 million cubic meters of material in just a single month, with even some refineries doing as much as 20 million cubic meters of some of the simpler materials such as iron. So at any rate, it definitely wouldn't be impossible to build a refinery that could process $10 billion worth of asteroid dirt every few months or so. But if the refinery was built on the moon, who's to say that you couldn't have 2 or 10 or 1,000? It's certainly theoretically possible, but it all comes down to setting this up in the first place. Once we have the industry established, we can be doing mining trips for absolutely massive profit margins, in hundreds of billions of dollars per year in a realistic scenario, and eventually many trillions. Plus, on top of that, we have to consider asteroid mining is a statistical inevitability for what we need to accomplish as a species. In order to become multiplanetary species, to have a long-term space colony on Mars, or to reach even further, we absolutely need to develop things like asteroid mining, and to build a self-sufficient space where things can be accomplished without having to always return to Earth. And so currently, with the funds being allocated and the rate at which the technology is developing, NASA is estimating that we could probably start this industry up as early as 2030, with proper missions, testing, and infrastructure being built all throughout 2040, with things finally becoming hugely profitable as soon as 2050. Now, certainly it's not going to be soon, but we could definitely expect to see it happen within our lifetimes. And realistically, this entire timeline can be accelerated significantly at any point, with just much more proper funding being put into it. So what I'm expecting is we'll probably see some slow progress, and then there'll be a huge discovery or development in the technology. And then all of a sudden, every single government's going to realize, hey, this is actually happening, and they'll pour massive resources into it, and then it'll be successful just a few years after that. And this tipping point could happen within the next decade, and certainly could ramp up very soon depending on the progress of the technology. And I, for one, will be very interested in seeing who becomes the first trillionaire through asteroid mining. Hey, if you enjoyed this video, watch this other one right here that YouTube believes is perfect for you. If you watch until the end of this video, you're just gonna get a bunch of ads. So hurry, go to this next video immediately so that you can be saved from the adpocalypse. This has been Jeremy B with Space Lore, signing off.